This video is about review for polynomial functions. Number 1, solve the equation 3x to the third power minus 19x squared minus 104x minus 60 equals 0. Given that 3x plus 2 is a factor, find all the zeros. Since 3x plus 2 is a linear factor, we will use synthetic division to figure out all the zeros. For synthetic division, one polynomial function divided by x minus c, we will use synthetic division. So we will change 3x plus 2 into 3 times x plus 2 over 3. Then find the root. X equals negative 2 over 3. Root in the corner, negative 2 over 3. No missing power. You have 3, negative 19, negative 104, negative 60. The first one drop down 3. For the fraction, we will divide it by denominator, then multiply by numerator. 3 divided by 3 times negative 2 is negative 2, adding negative 21. Divided by 3, negative 7 times negative 2 is a positive 14, adding negative 90. Divided by 3, negative 30 times negative 2 is a positive 60, get 0. Then do not forget divided by this 3. You will get 1, negative 7, negative 30. Then here's x third power. You have x squared, x minus 30. So for the polynomial function, 3x third power minus 19x squared minus 104x minus 60 equals 3x plus 2 times x squared minus 7x minus 30. For x squared minus 7x minus 30, we can do the integer x. That is x minus 10, x plus 3. So for the zeros, x equals negative 2 over 3, 10, negative 3. This is all the zeros of a polynomial equation. The cubic equation x to the third power minus kx squared plus 3k equals 0, where k greater than 0 has roots alpha, beta, and alpha plus beta. Given that alpha times beta equals negative k squared over 4, find the value of k. Since we already know all the roots of this cubic equation, we can use the sum and product of roots formula. For this cubic equation, we have a equals 1, b equals negative k, c equals 3k. The sum of roots equals negative b over a. We plug in alpha plus beta plus alpha plus beta equals negative b over a will be k. Organize, you will get 2 times alpha plus beta equals k. For the product of roots, x1 times x2 times x3 equals negative c over a. Because this n equals 3, so we have negative c over a. x1 is alpha, x2 is beta, x3 is alpha plus beta, equals negative c over a will be negative 3k. Then we organize. We know alpha plus beta. From here, we can get alpha plus beta equals k over 2. Then we plug in here. For alpha times beta is given here. Negative k squared over 4 times k over 2 equals negative 3k. Then we have negative k to the third power over 8 equals negative 3k. Multiply by 8 both sides, negative k third power equals negative 24k. We know k is not equal to 0. We can divide it by negative k both sides. We will get k squared equals 24. Square root k equals plus or minus square root of 24. And k equals plus or minus 2 square root of 6. Since k is a positive, so we get final answer k equals positive 2 square root of 6. This will be the solution to k. Let's go to number 3. Consider the function f of x equals x to the fourth power minus 6x squared minus 2x plus 4. X is all real numbers. The graph of f is translated 2 units to the left to form the function g of x. Express g of x in the form of this, where a, b, c, d, e are integers. For g of x, it's translated 2 units to the left. So g of x equals f of x plus 2. For every single x in f function, we will change into x plus 2. So we get x plus 2 to the fourth power minus 6 x plus 2 squared minus 2 times x plus 2 plus 4. For x plus 2 to the fourth power, we can write down x plus 2 squared times x plus 2 squared. So we have x squared plus 4x plus 4. Then x squared plus 4x plus 4. Then we will use a FOIL to figure this out. X to the fourth power plus 4x third power plus 4x squared. Then plus 4x to the third power plus 16x squared plus 16x. Then plus 4x squared plus 16x plus 16. Combine like terms, x to the fourth power plus 8x to the third power plus 24x squared plus 32x plus 16. So we get x to the fourth power plus 8x third power plus 24x squared plus 32x plus 16. Then minus 6 times x squared plus 4x plus 4. Then this distributive property minus 2x minus 4 plus 4. Then combine like terms, x to the fourth power plus 8x third power plus 24x squared. Then these two are like terms plus 30x this canceled, plus 16. Then distributive property, minus 6x squared minus 24x minus 24. Then combine like terms again. X to the fourth power plus x to the third power, these two, plus 18x squared plus 6x minus 8. Let's go to question 4. Let f of x equals x to the fourth power plus px third power plus qx plus 5, where p, q are constants. The remainder when f of x is divided by x plus 1 is 7, and the remainder when f of x is divided by x minus 2 is 1. Find the value of p and the value of q. We got to use the property of synthetic division. F of c equals remainder for possible root c. For x plus 1, we set up equals 0. Then x equals negative 1. For f of negative 1, remainder is 7, so equals 7. X minus 2 equals 0. X equals 2. Then f of 2 equals, remainder is 1, so equals 1. We will use these two equations to figure out p and q. F of negative 1. F of negative 1, we plug negative 1 into this function. You will get negative 1 to the fourth power plus p times negative 1 to the third power plus q times negative 1 plus 5. We organize. F of negative 1 is 7 equals 1 minus p minus q plus 5. So 7 minus 1 minus 5 is 1. You will get negative p, negative q. Divided by negative 1, we get p plus q equals negative 1. For second equation, f of 2 equals, plug in, 2 to the fourth power plus p times 2 to the third power plus q times 2 plus 5. That equals 1. 16 plus 8p plus 2q plus 5 equals 1. So we have 8p plus 2q equals negative 20. We get 8p plus 2q equals negative 20. We can divide it by 2. Both sides, you will get 4p plus q equals negative 10. This is the first equation. This is the second equation. So we put this together. 4p plus q equals negative 10. We subtract. 1 minus 4 is negative 3p. Cancel. Equals negative 1 minus negative 10 is negative 1 plus 10 is 9. So p equals negative 3. For the q, we can get negative 1 minus p. So negative 1 minus negative 3 equals 2. So the final answer, p equals negative 3, q equals 2. Let's go to number 5. Consider the polynomial q of x equals 3x to the third power minus 11x squared plus kx plus 8. Given that q of x has a factor x minus 4, find the value of k. When you talk about x minus 4 is a factor, which means q of 4 equals 0. We plug into this polynomial function. 3 times 4 to the third power minus 11, 4 squared plus k times 4 plus 8 equals 0. 4 to the third power is 64 times 3, 192. 192 minus 16 times 11, 176 plus 4k plus 8 equals 0. Combine like terms. So 4k plus 24 equals 0. K equals -6. So we have k equals -6. So we get this q of x equals 3x third power minus 11x squared minus 6x plus 8. For 5b, hence or otherwise factorize q of x as a product of linear factors. We will do the synthetic division to figure out all the linear factors or all the zeros. Root in the corner, no missing power, 3, -11, -6, 8. Drop down, 3. Multiply 12, 1. 1 times 4 is 4, -2. -2 times 4 is -8. 0. So here x to the third power, x squared plus 1x minus 2. So we get the factor x minus 4 and 3x squared plus x minus 2. For 3x squared plus x minus 2, we will do linear x, -6, 1 over 3 over 3. So 3, -2, 1 over 1, x, x. Bottom up, your final answer will be x minus 4, x plus 1, 3x minus 2. This will be the solution to 5b. So when you look for all the zeros of polynomial functions or all the linear factors of polynomial functions, synthetic division is a good way to figure those out.